Throughout history, we have developed vaccination to protect both humans and animals from a wide range of preventable and potentially serious illness. With vaccines, we can take advantage of one of the most important aspects of human immune system, the ability to develop immunological memory. This means that once the person or animal is exposed to a particular pathogen, in one word, anything that can cause illness, they will develop resistance to infection with the same pathogen in future. Our adaptive immune system contains the white blood cells known as T and B lymphocytes. These become activated during the first time or primary exposure to the pathogen. Once the pathogen has been fought off by our body, the population of these T and B lymphocytes known as the memory cells. Those memory cells remains in the individual. These memory cells remains on standby, ready to react quickly when the individual is re-exposed to that particular pathogen in what is known as secondary exposure. The immunological memory helps the immune system respond much more rapidly and effectively than during the primary exposure. As a result, the individual is generally protected from the development of disease symptoms. Now that we know about immunological memory, that what about vaccines? Well, it simply means that we generate the memory effect artificially and at the early stage to prevent future disease. This means we inject a weakened version of pathogens, inactive pathogens, or just particular part of the pathogens into the individual we want to protect. In healthy individual, these vaccine components activate a specific immune response mimicking primary infections but weak enough not to cause the development of the disease symptoms. For example, the varicella or chickenpox vaccine involves infections of a weakened version of Varicella zoster virus in a healthy individual. This weakened virus will not cause chickenpox symptom, but it will activate an immune response. As a result, when the vaccinated individual comes across the Varicella zoster virus again, for example, from a person infected with the chickenpox, he or she will mount a rapid memory immune response to the virus and will not develop chickenpox symptoms by taking advantage of immunological memory. In this way, vaccination prevents and controls the spread of a wide range of illnesses including polio, smallpox, whooping cough, measles, and seasonal influenza viruses. In recent years, there has been controversy over the safety of vaccination program. To date, all credible scientific evidence strongly supports the importance of vaccination in avoiding preventable illness in individual and populations. So there you have it, vaccination then trigger our immune system to develop memory cells ahead of time, meaning our immune system is ready to launch an attack as soon as a pathogen enters the body.